morning, students. We'll start today the new concept, plane. We'll study plane. Very important thing it is. Now, first of all, I just want to pull one example of plane. You can have lots of example of the plane. You have seen around you lots of example of flat surface. This is one of the plane. Can you see? It's a flat surface. It's a plane. So the thing which I want to tell you, very important. We have lots of points on this plane, infinite points on this plane. One point definitely will be taken, P, which is variable point, which is normally called x, y, z. In the coordinate system or in vector form, the position vector of P will be taken R. So I would tell all this after in the concept. This is the plane. What the important thing that is, can you see this line, and can you imagine that this is a plane and this particular, which is the perpendicular on the plane, it may be anywhere on the plane, it works same. This is called normal of the plane. This is called normal of the plane. Again I repeat myself, this is a flat surface which is called a plane, where infinite points lie on that. One point P can be taken on that as a variable point whose coordinate normally taken x, y, z in coordinate geometry, and in vector it is taken position vector of P is small r. This line is perpendicular on the plane. It is called the normal of the plane. It works same if it is drawn here, if it is drawn here, if it is drawn here, no matter at all. So this kind of situations first create in your mind. Now let me extend the study. Suppose this is the plane, and first of all I am telling you the vector equation of plane. I am first telling you vector equation of plane. I would request you that if you are not good in vector, no matter at all, keep remember the formula of the geometry only. But we will initialize a concept from the vector. I will tell you each and everything. Then after we'll conclude the thing and I will abstract the thing that what the major thing we can remember. Okay, can you see? This is the plane. This is my plane. This is the plane. And I just want to give you an example also. This is my plane. Now I put here origin point. Suppose this is my plane and this chalk is the origin point here. Now I am drawing a perpendicular on the plane from the origin point, which actually crosses the plane and comes up like this is the perpendicular from the origin to the plane and it goes upside, which is called the normal, which is called the normal of the plane, which is called the normal of the plane. What is called normal? The line which is perpendicular to the plane. And intentionally I have drawn it from the origin point, and I take that this distance is d. Again I repeat myself. This is n, suppose ON, which is perpendicular from O to the plane and it goes upside on the plane like that. Can you see? This is the line which is actually this one tip of this line is O and this is drawn like that. Its a bottom tip is O and this point is called N and this distance is D. This distance is D and it comes up like that. After crossing this plane, it comes up like that. So this is the normal of the plane. Now I tell you that this distance is taken D. So keep remember in the mind that what we are finding vector equation of plane. In first thing that for particular we must know the perpendicular distance of the plane from the origin, which is called D. And second, I say something, suppose that I want to convert that D in vector form. I want to convert that distance D in vector form. If I ask you that ON distance is D, but what is vector ON? So whenever you need to convert any distance in vector, take one unit vector along that. So I am taking n cap as a unit vector along this perpendicular or normal. So when n cap is taken here, this distance is called dn cap. You don't be surprised. But I tell you one thing. You remember that IJK concept. Okay, let me tell you. This y-axis, this is taken J. Suppose it is point P, X, Y, Z. You draw the perpendicular. This distance is a Y. But in the direction of J cap, this OM vector will be called YJ cap. It is called YJ cap. Because unit vector J cap is along that direction, so any distance can convert it in the vector by helping that unit vector taken along that vector. Okay, so this is the same thing I adopted here. This is my n cap unit vector I have taken along this particular direction, and this distance was d. So definitely, if I want to convert that ON as a vector, this is gonna be d n cap. Now this is, suppose any point P I have taken on the plane whose position vector is r. That's simple. You know, P is a variable point whose position vector is normally taken r. I have taken O is my origin point. So ON is dn cap, OP is r. Everything clear now. Now let's look the next. Would you think that NP and this angle is none other than it is 90 degree? So I will try something here. That can you see in picture ON, vector ON and NP both are perpendicular. Look at ON and NP perpendicular. So when two vectors are perpendicular, what happens? Their dot product always gets 0. You should remember when two vectors are perpendicular, their dot product always gets 0. A perpendicular to B, it means A dot B is equal to 0. Same as I have taken. So what is the meaning of ON? Can you see ON is a dn cap? I will write dn cap here. Dot product NP. So NP will describe the NP with the help of O. So NP meaning position vector of P minus position vector of N. That's very simple definition. In vector we studied that NP. Now dn cap is equal to OP. OP meaning what? R. I will write here. ON. ON is a dn cap. Again I will write here. Is equal to 0. The next thing is very important. D is a constant number. N cap is a vector which constant number can transfer in the denominator of 0. Just it was in multiplication, now comes in division. So definitely n cap, d n cap is equal to 0 upon d will be coming and 0 will remain there. Hope you understand. And then I will multiply dot product. Look at n cap dot r minus d n cap dot n cap, meaning n cap square. You remember that vector A dot vector A is equal to A square, meaning mod A square. Here n cap square meaning mod n cap square. And you know that. Do you know that that dot product is commute? A dot B and B dot A same as n cap dot r and dot n cap both are same. Minus this is d. Why? Because n cap square meaning mod n cap square. And n cap is a unit vector, so its mod is 1. So we do transfer that side. So r n cap equal to d. What the final conclusion? This is the vector equation of plane in normal form. Very good thing it is. I am writing the good thing that vector equation of plane in normal form. Normal form. First topic is vector equation of plane in normal form. Can you read it? R dot n cap equal to d. Now, if you will look the formula, you need something. That what you need? R will be remain same. While finding the vector equation of the plane, this will be same. N cap is very important. What is n cap? N cap will be the unit vector perpendicular to the plane. That is your plane. That is your plane. So this is your n cap. So you need that. So how you will need it? I tell you, n cap is very important word. And cap always contain the cosines. This is all about depending on your hard study. Otherwise, you will get confused. And this topic gonna be one of the hardest ever for you if you are not having a good concept early in the classes which I taught you. So try to understand. I'm telling you. This normal, this is the normal, which is n cap I took. This is the normal, and n cap I took along that. So you don't afraid about n cap. You must need n. So what is n? N, the vector which is perpendicular to this. This is n actually. Sometimes student can confuse that what is n cap, what is n cap. You don't escape behind the n cap. N cap is just a unit vector along that n, along the vector. So this is none else but it is only n, and n cap is a unit vector. So what is n? Again I speak something. N is the perpendicular vector of the plane, normal vector of the plane, and it contains the ratio. You remember that r equal to a plus lambda b was the equation of line, where b was the vector which contains the ratio. Same as here in the plane, n will be the vector which contains the ratio of normal, and if you know n, you can find out n cap. So no worry about that n cap, it will be known easily. What is d? D is one of the important things. D is perpendicular distance of the plane from the origin point. That is one of the very good concept, that this is the plane, this is your O, this is the D, distance D. This tip, the and, the bottom and is called O, this distance called D, and this is actually across the plane, and this is called N, where n cap is none else but it is a unit vector along that n. N contains the ratio of the normal of plane. Please here listen this sentence twice and thrice. N is the actually it is a ratio vector. It contains the ratio of normal of the plane. When you know n, you can find out n cap, because n cap can be found out by n. That's simple. Again I repeat one thing. N contains the ratio and n cap contains the cosine. You don't worry about that. So I will tell you each and everything. So that D is very important. Again I speak one thing. This is called the normal, the vector equation of plane in normal form. Normal form. I wrote here plane, sorry. Normal form. Normal form. And whenever you will be told to find the vector equation of the plane in normal form, D must be given. If D is given, you can only use this formula. And D is particular. D is particular. What is D? D is the perpendicular distance of the plane from the origin point. So D must be given. So if D is given, you have to use this formula. N cap will never be given. You will be given N. What is N? What is N? It is the ratio vector of ratio of normal of plane. This is the plane, this is normal. And n, vector n will be taken here in the direction of this particular normal, which contains the ratio of this normal. So if you know n, you can find out n cap. So I think it is enough to speak about all. This is the normal form. Now I would change something from my side. Please try to understand it. I again tell you that when we talk about that plane, this is called n, and it contains the ratio. So I would write ratio as AI, BJ, CK. Please try to understand it. And always taken like that. A, B, C are the ratio of normal of plane. You can repeat. When you will, while looking the video, watching the video, you can repeat that n is it contains the ratio of normal of plane, not ratio of plane. Ratio of plane is a wrong language. Ratio of normal of plane is the right language. Okay, now after finding n, so I tell you that n contains AI, BJ, CK. When you will find n cap, do you know the definition of n cap? You know, vector n upon mod n. So AI, BJ, CK upon mod n. A square, B square, C square. Now separate it. A upon A square, B square, C square, I cap, B upon same J cap, C upon same K cap. What do you think? A upon A square plus B square plus C square. You remember that? When ratios are A, B, C, then A upon A square plus B. What is this? This is the L cosine. this is L, Li, then Mj, and then Nk in n cap. Now compare these two things and feed in the mind that only n contains the ratio of normal of plane and n cap is containing the cosine, laminar cosine of normal of plane. So that is very important thing, that this n cap is what? This is actually containing the cosines. So I again tell you one thing, that the n cap will not be given directly, only n will be given. In what language? Sometimes it would directly given that the plane is perpendicular to the vector, it means that it is n. Sometimes it may given that the ratio of normal of plane are 2, 3, 5. So 2i plus 3j plus 5k will be your n. So something like that. So we have to be familiar with the language of the question. So definitely we'll look after about the examples. First of all, I want to extend the study a little bit here. This is my normal form. And I want to do something here. Look at, can you see? R dot n cap. I'm changing a little bit. N cap, I'm writing n cap as vector n upon mod n equal to d. Can I write vector n upon mod n? And lastly, R dot n will be, I transfer here nd dn, whatever you can write, say. And R dot n equal to that nd I write d dash or something like. Because n is constant value and d is also constant value. When these two will be multiplied, you will again have constant value. So constant value you can write by any way. So this is none else but it is also equation of plane, not vector equation. Please try to understand. It is vector equation, sorry. It is a vector equation of plane, but not in normal form. It is in normal form. It is general form. It is general form. General form. So now you student can think that what is this and what is particular this. This formula will be used only when d is given. But d is particular actually. D is a perpendicular distance of the plane from the origin point. But this formula is only the general form of the plane where d dash is not the perpendicular distance. D dash is just a constant value. N is particular. N is what? The normal vector of the plane which contains a ratio. This contains the cosine. This is the perpendicular distance and this is only constant value. So ultimately I tell you one thing. You remember last year we studied about the line ax plus by plus c equal to 0. This was general form. But except it we had a lots of form. Y equal to mx plus c. You know, y minus y1 equal to mx minus x1. You know, y minus y1 equal to y2 minus y1 upon x2 minus x1 bracket x minus x1. You know, x minus a x upon a plus y upon b equal to 1. You know, x cos alpha plus y sin alpha equal to p. You know, so lots of forms ultimately comes in general form. So whatever formula you will use among them, you will get a general form. Similar here, when you will use this formula, ultimately you will get a general form. So this is general form. Now student, just compare. This formula only will be used when d will be given. What is d? Perpendicular distance of the plane from the origin point. What is n cap? N cap is a normal unit vector of the plane. N cap will not be given directly, n will be given. So first of all get your n, then find n cap, then use the formula and get answer. So hope I think we have I have already spoken a lot about that. We want to look for one example. Don't forget the formula. And let's look. One question I want to do here. Example number 30. Find the vector equation of the plane which is at distance 6 by root 29 from the origin point, and the normal vector of the plane is its normal vector from the origin is 2i minus 3j plus 4k. Would you think that it is in your hand? The question is very easy. We want to find the vector equation of the plane whose distance from the origin point is 6 upon root 29, and what it is told that normal vector, normal meaning perpendicular vector from the origin is given 2i minus 3j plus 4k. Now this is the question. Now you may think that why it is n? You took n cap last time. I tell you that whatever the given vector, it is not n cap, because n cap contains the cosine L, and these are not L. You know what an element? You should know the range of element. -1 to 1. This is range of element. You can identify by the terminology that element, they are cosines, and the range of element are -1 to 1. Also, L square plus m square plus n square always 1. So you can check now. L square plus m square plus n square is not 1. It means it is not element. If they are not element, so it is not n cap. So it is only n. So normal vector is always called n. So this is your n, and perpendicular distance is given this one. So you will write the solution that given that perpendicular distance is 6 by 29, which is called d, and n is a normal vector which is 2i minus 3j plus 4k. Now you will go with the formula. That formula was r dot n cap equal to d. This is a formula. It is a vector equation of the plane. And why I use this formula? Because d is given. D is given. This is d. And r dot, what is n cap? You know, vector n upon mod n is equal to d. Now put in the value. R dot, what is n? N is 2i minus 3j plus 4k upon, this is 4, 9 and 16, and d was particular, d was given that 6 by 29. Now r dot 2i minus 3j plus 4k, this will be 29, and this is a 6 by 29. So these two will cancel. Lastly, whatever the answer you will get, this is general form. If you remember my words, this is answer. Now try to see and make the habit to see the answer, the kind of answer this is. R dot n equal to d. That d dash, whatever you will say, I tell you one thing, that r dot n cap equal to d, r dot n equal to I wrote d dash. If I am writing d also correct. But don't get confused that these two d are different. This d, because n cap using, so this d is a perpendicular distance of the plane from the origin point. But this d is a simple constant number because that is n. So it is general form, it is normal form. So this is general form. Can you see? R dot n equal to, that is not the perpendicular distance of the plane of the origin. This is only constant value. So this answer is general form. So what the formula of plane if you use, lastly you will get general form. You don't worry about that. So lastly you will get r dot n equal to d dash, whatever you want to say you can, no matter. But that is constant value. Only constant value. So student, hope you have got here. This is my answer. You can understand it. It is my answer. So this formula is a restricted formula. Only it will be used when d is given. D is a perpendicular distance of the plane from the origin. N cap will not be given directly. As you can see in the example, that n was given only. N is what? Normal vector of the plane. Instead of that, what language can you use? The ratio of the normal of plane are given 2, minus 3 and 4. You should understand that by which you can create n, and you can make. And after making the n, you can find n cap and get your answer like that. Okay. Enough to speak. Student, do hard work regarding that. Otherwise, it's gonna be tough to you. So, go for that. Now, next question. We have example number 14. Let me speak. Let me talk about more about that first. I have now vector equation of the plane in normal form. What the formula? R dot n cap equal to d, where d is a perpendicular distance of the plane from the origin, n cap is a normal vector containing cosines. Okay, I want to convert that vector equation in Cartesian equation. So we will look for the Cartesian equation of plane in normal form. So how we can convert? Definitely very simple. R is what? You remember that? I make a picture again. This was n cap, this is D, and this was a point P whose position vector taken R. And whenever P is taken, whose position vectors are, when we convert that in Cartesian form, we take it is xyz. So always R is xi plus yj plus zk dot. What is n cap? Please try to understand. N cap contains the cosine. I taught you, I made you write also, that n cap is always Li, Mj, Nk. Nk. L, M, N, they are what they are? They are direction cosine of normal of plane, which contains in n cap. Okay, now D is perpendicular distance of the plane from the origin point. That is simple. Now can you multiply dot product? I, J, J, K, K. You know it's gonna be Lx, My, Nz equal to D. That is the what form? It is a Cartesian equation of plane in normal form. So this is a very simple. This time Lx plus My plus Nz equal to D, where L, M, N will be direction cosine of normal of the plane, and D is a perpendicular distance of the plane from the origin point. That is very simple. Now again, I want to look here general equation of plane in vector form. What is the formula? R dot n equal to D. So can you make the comparison between these two? This was n cap. So D was perpendicular distance of the plane from origin. But this is D. I wrote D dash early in the instant. But this time I am writing D. You please don't get confused about D and D. This D is particular because n cap was using. But this is only n now. This is normal vector of the plane. So this D is an ordinary number. This is not the perpendicular distance. Keep remember. Now I will convert that only vector in Cartesian form. As usual, R will be xi, yj, zk, and what is n? So it was n cap. I took lmj, lmn. Now this time it's a simple n. So it contains ratio a, b, c. Try to understand. This n is actually here. In the same direction, you can you can take n or n cap, because n cap is none else. It is a unit vector along the n, which contains the cosine, and n contains the ratio. So this is only n, a, b, c. A, b, c are what? Ratio of normal of plane. Okay. Now you can multiply. You will get ax, by, cz equal to d. You can convert here. Ax, by, cz equal to d or plus d or something like. Sometimes students can confuse about that. What is this? What you write? I again tell you, you don't bother about d dash or something like that. If I am writing only plus d, you please don't get confused about that. Why? Because d is a very constant number. If you want to be sure, you can take d dash, minus d dash, and minus d dash. I am saying it is plus d. D dash is constant, plus d is a constant. This is general form. I want to make it so that I did all this so-called silly work, that it was d dash, no matter if it is supposed to be d. It was minus d dash, no matter. I wrote minus d dash equal to d plus d, no matter, because d is ultimately constant number. So whatever the answer you will get, guys, this will be a general form. This is one of the very important and vital formula. Ax plus by plus cz plus d. This is general form in the Cartesian form of the plane. Whatever the procedure you will use for finding the equation of plane in Cartesian form, you will get same answer. Ax plus by plus cz equal to plus d. Where a, b, c are very particular. I want to write here where a, b, c are direction ratios of normal of plane. This is very important language. Sometimes student used to say a, b, c are ratio of plane. It's a silly answer. You don't reply like that. A, B, C are ratios of normal of plane. That is important thing. So student, this was all over about that. This formula is restricted. Many times in between lecture I taught you this one. And this is the general form in the vector concept. This is Lx plus My plus Nz equal to D is your Cartesian form in normal equation. You can see Cartesian equation, normal form, and this is only the general form in Cartesian concept. So this is all about the plane. Many things still remaining, but it was just to initialize the thing, which was very important to know. Okay, in next section we will study more about that. Thank you.